method, and for those who don't know, this is for those who don't know or don't like cricket. Here's what one-day cricket is. It's a game between two teams where each team plays an innings, and both teams get 50 overs, and both teams have 10 wickets. Okay. The goal is the following: the team batting first, let's call that team 1, it tries to maximize its score using its overs and wickets. Now the thing is, it tries to maximize this because the bowling team is essentially going to chase this particular target. So it has to essentially try to set a target as high as possible. And of course the bowling team's goal is to keep it as small as possible. So that's, let's call that team 2. It tries to restrict the score because this is going to be this particular team's target during its innings. So the bowling team then gets to bat and tries to reach the target within 50 overs. Okay. So this is a shorter version than Test cricket. I think all of us have grown up with it, whether we like it or not. And the good thing about this is that it always has a win or a lose outcome. Well, almost always has a win or a lose outcome. Occasionally there are some ties, and they are a lot more exciting as well. But of course now there is a even shorter version that has taken over. But we'll study the 50 over one. It also, this format became popular in the 70s, 80s, 90s because compared to Test cricket, it often leads to exciting finishes. Okay. When you have a match where you want an outcome, okay, a positive, that is an outcome where one team wins and the other team loses, it's not good to have this particular game messed up by weather. Bad weather often leads to very interesting twists and turns in Test cricket. I don't know how many of you have essentially followed Test cricket, and here is a team that's struggling to save its wickets, and everyone is watching when it'll rain. Okay, so that the team could essentially get some time thanks to the rain, and then somehow manage a draw. So it often leads to very exciting twists and turns in Test cricket. Also, the pitch, the nature of the pitch changes significantly when it rains in Test cricket, and that also leads to some excitement, some radical outcomes and so on. But in one-day games, you don't want this to happen. So you want essentially rain to be as far away as possible, and it's not tolerated in this result-oriented format. So there simply isn't time, unlike in Test cricket, for the match to continue on another day. So there have been occasions when reserve days have been used. So do any of you remember any games where reserve days were used? Okay, yes? Okay, and so what did they do at the end of? Yeah, the trophy was shed. But they did have a reserve day in the hope that they could complete the game on the second day. But it turned out that the rain gods had another thing on their minds. Anyway, draw is not a good outcome in knockout competitions anyway. So if you want to essentially declare somebody as a winner, we don't want a situation where the cup is shared. It's not exciting at all. So we don't want draws. So that's why even in soccer you have the penalty shootout. So the game could have been extremely close. Maybe one team in football possessed the ball significantly, made several attempts to score, and then eventually comes this situation when the match is decided by penalty shootout, and then the other team wins. So such things are not good to have, but nevertheless you want some outcome, and therefore you settle for such a thing. So what we would like to do, but rain is sure to come in many matches, particularly if you hold a match in Bangladesh during the rainy season, it is bound to come. So we would like to essentially come up with a means by which we continue with the match, maybe revise the target, shorten the length of the game and so on, and then come up with an outcome. Okay. All right, decide a winner based on the state of the match if play can't continue. So suppose you have to stop the game, so you have to decide who the winner is. Okay, I want to give a few examples, some prior approaches through some examples, and then we'll see some shortfalls of those approaches, and then I'll tell about the Duckworth-Lewis method. Okay, so this was a method that somebody used to essentially come up with an outcome. It's called the average run rate method. It's actually the first method that you would think of. If you were to come up with a rule, to decide who the winner is, and you didn't think about it too much, this is the method that you would come up with. And given the lack of experience with such with the nuances of the game, that's precisely what the first people that came up with the method used. So here's the example. This is something called the Benson and Hedges World Series Cup. It used to happen in the 80s and the early 90s. Is there anybody here who was around during the 1988-89 time? Okay, yeah. But these were exciting times for us because we were growing up, and every one of us that played cricket dreamt of making it to some level. So we were all avid followers of this game. So I remember watching many of these games, particularly the Benson and Hedges World Series Cup. So this is the third final between Australia and the West Indies. Okay, those teams are still there, so it's not all that irrelevant. Okay, what happened was Australia scored 226 for 4 of 38 overs. And it so happened that actually once the game started, there was, within the very first, after the first few overs were bowled, rain actually stopped play. And that's why they had to essentially bring it down to 38 overs in the first place. And so 2 hours of play was lost. There was a 2-hour delay. And this was, I say initially, but it was actually during the initial parts of the Australian innings. There were about 4 overs or thereabouts which were already played during Australia's innings. And so the match was reduced to 38 overs and Australia scored 226 for 4. West Indies followed, and at some point of time they needed 180 runs of 31.2 overs. Okay, so 180 runs of 31.2 overs, and rain stopped play. And this time rain stopped play for 1 hour 25 minutes. Now I don't know how many of you are familiar watching the game. How many of you essentially keep track of how many overs to bowl and so on. But in 1 hour 25 minutes, how many overs can you bowl? Or how many overs is a team that's bowling supposed to bowl? Around 20. Okay, that's about right. So you're supposed to bowl about 15 overs in an hour. Okay, between 14 and 15 overs in an hour, and that amounts to about 4 minutes per over roughly. And so that's 15 plus another 6, so roughly 16 overs or so. So 15 to 16 overs. Sorry, 15 plus 5, 20 overs or so is essentially what was lost. And so that's exactly what happened. From 31.2 overs, 20 overs were docked off, and West Indies was asked to score something in the 11.2 overs that were left. Okay. Now, what did they do? They used what is called the average run rate method. So they found out at what rate Australia had scored. Okay, that's 226 over 38 overs. That's a certain run rate. If 20 overs are docked off, let's actually remove exactly that many runs per over times 20 overs. Okay. That's called the average run rate method. So this is what you would naturally use yourself in your street cricket encounters, for example. And they came up with a revised target of 61 of 11.2 overs. I think they had several wickets in hand. Okay. Yeah. So 2 of the fantastic openers from West Indies of that time were Desmond Haynes and Gordon Greenidge, and they would have just chopped this off in no time. Okay, so 61 runs of 11.2 overs. They actually easily won with 4.4 overs to spare. Of course, now in T20 cricket, this is, as Rajinikanth, the superstar Rajinikanth would call, he'll call this jujube. Okay, so West Indies won quite easily with 4.4 overs remaining. What was the problem here? West Indies had it too easy. Why? They had wickets in hands, yes. Correct. They had several wickets in hand, and they had only 11.2 overs, so they could essentially afford to take a significant amount of risk and score this in a much faster time than 11.2 overs. Okay. Therefore, if you were to revise it now, keeping in mind the hindsight that we have, that they have wickets in hand, what would be a guess of what the target would be? By the way, I should ask some questions, right? Okay. So I think you should give something to that person. Who answered this question? They had wickets in hand? Okay. Okay, so there is, okay, all right. So maybe I should warn them that there is possibly a reward and then ask the question the next time. Okay, what would be a good target to set for West Indies? Sorry? 11 point? Sorry, I didn't follow. Somebody said 11 point something. In 11.2 overs. How much would you set? What target would you set? Around 100. Well, actually, doesn't it depend on, like, for example, suppose West Indies needed 180 of 31.2 overs, but they had only 1 wicket in hand. What would you do? Okay, so we have to think about, or if they had all 10 wickets in hand, what would you do? Okay, so we'll have to think about this, okay, a little bit more. And that's the content of the next example. And here's a hypothetical example. So suppose team 1 plays 50 overs and it scores 250. Okay, so maybe when I grew up, this was a good score. Maybe now I should have 300 or 325 or something like that. But the run rate is 5 per over, and so it enables easy computation. Team 2 replies. Okay, Rain somehow stops play at around this point, at the midpoint. But team 2 has scored about 120. Okay, and they have not lost any wickets. I pointed out that perhaps we have to take wickets into account. Let's see what should happen, and this should essentially make us or get us thinking. Team 2 replies and it has scored 120 for no loss in 25 overs. Rain has stopped play. Okay, who's the winner? Remember that we have to declare a winner because this is one-day cricket. Okay, where it's team 2. Team 2 is the winner. Why did you say team 2? They have all wickets in hand. Okay, so if you employ the average run rate method, though, according to the average run rate, ARR stands for average run rate method. What is called par score, that is the thing that they have to cross. Okay, that would be the revised target. The par score, according to the average run rate method, is they had played 25 overs. Team 1 scored at the rate of 5. 25 times 5 is 125, and so they need to get to 125. They are equal. 126 they win. Okay, that's the average run rate method. All of you said 120 for no loss. Team 2 wins, right? So you said team 2. You will declare team 2 as the winner. Okay. So according to the average run rate method, team 2 loses, and you all somehow agreed that it's not fair to team 2. Okay, so somehow you've said that team 1 should lose, team 2 should win. What if it was 120 for 2? 120 for 9. Okay, let's see, 120 for 9, that's easy. Team 1 should win now all of a sudden. So the par score that they must cross is essentially something that, so the par score for 120 for no loss should not be 125, it should be something that's smaller. Okay, but the par score when their state is 120 for 2 should be a little higher, and the par score when they are 120 for 9 should be even higher, so that you declare that they are below the par score and therefore team 2 loses. How do you come up with what the par score should be? Okay. Okay, so in a situation, so that's an important consideration. So in a game where team 1 played and scored 250, I didn't tell you how many wickets team 1 lost. Maybe team 1 on the 50th, on the 49.6, that ball, they lost their last wicket. Okay, in that situation, what would you do? In another situation where it's 250 for no loss, what would you do? If the match did not get interrupted by rain, does it matter? Yeah, so okay, so what you're saying is that it's the state here, the number of wickets that it has lost, that matters. But her point is that, does the pattern of the wickets lost, does it matter? Should it matter? From this stage on, should it matter? What are your thoughts? I mean, every answer is a correct answer here. So let's see if you can justify it. First, let's hear you. Okay. But how does the fall of wickets up to that time matter? It's only the fact that 9 wickets have been lost and they have only 1 more wicket in hand. How does the fall of wickets actually matter?
Similarly, now under 25 overs, you lost 2 wickets. So on an average, up to 12.5 overs.
Okay, so that means you're looking at only the average number of wickets, number of balls bowled per wicket. That's here. All that information is here in the 9 wickets. Just as 250 in 50 overs has all the information that you need. So the actual pattern of the fall of wickets is inconsequential. And if you want to find out at what average rate it has fallen, it's here in the 120 for 9 state. Next person. Somebody else had a question. All the? Okay, so okay, so what you are also saying is that in addition to the fact that they have lost 9 wickets, you need to also take into account which batsman is playing. So, for example, if it is Harbhajan Singh and let's see who else, Varun Arun.
This over had been 127 instead of 120. Then we would have declared team 2 as the winner.
Yes.
So that would have been unfair for team 1 because they were able to drop 9 wickets. They were still able to drop 9 wickets in 25 overs. So even though the pattern does not matter, this fact matters that
they've lost 9 wickets must matter. So that makes sense, right? Because what you're saying is that they have lost 9 wickets must matter, so that you can declare here that team 1 is the winner. But which wicket they have in hand, somehow you should not take into account, just because for the same philosophical reasons that who scored those 250 runs there does not matter, it's only the target that matters. But one could argue that no, you should also see which batsman is playing and come up. One could make a point, and you have to essentially make some decisions here. One more question.
for 9 wickets that's fine, but suppose it was 120 by 4 and we had a very good player at 5. And if team 2 was declared as they lose, but they had a good player at 5, so they could win too.
So in other words, what you should also do is you have to keep track of the past averages of each of the batsmen that are surviving, and you have to essentially set a target based on that. Well, you could do that, which means that let me take it to the extreme. Sometimes the way to address these questions are I have to take it to the extreme. So let us say that what is the best team now? India. Okay. So, and what's the worst team? Zimbabwe. Let's say that India and Zimbabwe are playing. Okay. Why should they even play? Why don't we take into account the past averages of the batsmen, and why don't we take of the batsmen from India, and why don't we take into account the past averages of the batsmen from Zimbabwe, and then just decide the game up front? So what I have done is I've essentially taken the suggestion that you have, and I've taken it to the extreme, and I've said that rain has stopped play. Declare the game right at the beginning. No overs were bowled. Declare the game right at the beginning and just say India has won the game. Is that a good outcome? Okay, so somehow then you shouldn't, if that is the case, by this example of taking your argument to the extreme, I hope I have convinced you that perhaps you should not take into account who the batsman is. Okay, all right, but you probably should take into account how many wickets have been lost and so on. Okay, so interesting. So these are the kinds of questions that one must raise and one must address. Let me just make my point. One must address before you come up with a method that becomes applicable. So it's not an easy task to devise a method that will be accepted. It will, no matter what scheme you have, it will always be criticized, but it should find wide acceptance, and you have to address a lot of questions. You had a question.
Why not consider the game that the other team won was at 25?
No. For the following reason, that the pattern of play for the first team does not matter. It's only the target So the rules of the game are that in an uninterrupted game, it's only what the target that the first team has set that matters, right? So if you essentially take into account the pattern of play, that's a legitimate rule that you can set, but you must set it up front. You must tell it up front so that the teams can essentially take that into account, and then that becomes a new game. Maybe you should call it cricket instead of cricket. Okay. No, but the thing is the fact that there is always the possibility of a rain. If rain comes and stops play, what should be my strategy to win is something that's there in their minds. They are always the players at any stage are essentially thinking about every eventuality and they are preparing for those eventualities. And therefore, you have to take into, so the rules of play become different when you essentially make the suggestion that you make.
And try to compress it. Generally, in the last overs, you take a higher amount of runs scored and a higher amount of wickets scored.
Okay. So we'll see how that's taken into account. Yes. Okay. So we'll see. So something like that is what is being done. Yes. Last question, and then I'll move forward. Yes. Yeah, it could be a batting pitch or a bowling pitch. It could be, yeah, that's true. You could take into account in this particular pitch, like for example, Bangalore. So what's the nature of the Bangalore wicket, KSCA Stadium? It's a batting wicket. Why? It's a very small ground. The ground is fantastic. Water drains dramatically fast, and then it goes all the way to the boundary. That's it. So it's a fantastic. I mean, I hope all of you have gone and seen the ground. It's an amazingly fast wicket and slow, and a batting wicket. So perhaps what one must take into account is not all games, but games in this particular ground. How were they played in the past, and then you might have to set a target. So this is another consideration that was taken into account. For example, in Sydney Cricket Ground. What's the characteristic of Sydney Cricket Ground? Batting wicket, but it's also one of the longest wickets, right? So spinners can essentially drain the batsmen because you just can't loft them all the way. So you can essentially, thanks to the long boundaries, you can essentially take those catches. You can essentially set a field that drives the batsman nuts, and he hits and he gets caught at the boundary. So there are some interesting things that arise which are ground dependent. So how do you take those things into account is something that has bothered people, but in the current method they haven't taken these ground factors into account. But what they have taken into account is the history of all past games without any regard to the ground. Maybe you can take the ground situation into account, because the game is being played here. You should make use of that fact in some way, right? So it is a legitimate approach, but no one has taken, and perhaps one of you can think about doing such a thing. Okay, anyway, so it has gone into auto search. Okay, I have another 25 minutes, okay. All right, so let's actually look at another example. Sometimes you have to do stupid things to be able to come up with something better. And here's the most stupid rule that was ever devised. Okay, and I want to essentially highlight the comical aspect of this particular method, although one of the teams was eliminated and that was a tragic outcome because of this method, but nevertheless it has some comic relief. Here's the situation. It was the 1992 World Cup semi-final. Okay, England versus RSA. England made 252 for 6 of 45 overs. The match was actually shortened because of rain at the beginning, and so they said that okay, We have lost 10 overs. So I'm going to give each of these teams 45 overs, 45 overs. So that it's a 45 plus 45 over game. England made 252 for 6. Okay, good score during those days, 45 overs. And South Africa was chasing. Okay, and they were 231 for 6. Okay, that means if you do the calculation, 21. Yeah, 22 runs needed, and they had 13 balls left when rain stopped play for 12 minutes. So in these T20 days, what would you think of this particular score? Oh, South Africa should have essentially won. Okay. In these T20 days, but during those times, you have to essentially rewind to those times when things were slow. Jonty Rhodes was there, by the way. So, but things were slow. This was actually a tough score. It was a nail-biting finish. RSA had a chance, but I think England possibly had the upper hand at that time. Okay, rain. Okay, rain stopped play for 12 minutes. Okay, that's roughly how many overs? Well, actually, for 12 minutes, you can bowl 13 balls. So the match must have been called off. But they actually said, no, we should give South Africa a chance. And they said, okay, we'll remove from the 13 balls, 12 balls. Okay, you get 1 ball. Okay, but what do you have to score? So here's what they had to score. They had to score 21 runs of the last ball. Okay, is this impossible? 21 runs of the last. So quiz question. Okay. Okay, so whom do we? Okay, maybe I'll ask another question. So maybe this, because every one of you answered, I can't give a reward for this, but maybe another one. Okay, so it is not impossible, but come on. Do you know of a situation where Australia and New Zealand played? And there was a similar situation where they had to score a 6 of the last ball. Okay, and what happened during that game? This was a disgraceful situation for Australia. Yes, okay. So who was the person that... Okay, now, who was the person... Sorry? No. For this question, whoever answers will get a reward. Okay, what's the question? Sorry? No. Who was the captain? Okay. So I think you should give it to him. Yeah. Okay, so it was a disgraceful situation where they had to score 6 runs of the last ball. And what happened was there was quite a bit of discussion. And there was a Benson and Hedges game that was played in the United Kingdom that essentially disallowed underarm bowling. But they had taken that particular phrase off and they knew about it. And so underarm bowling was technically legitimate. And they even told the New Zealanders that we are going to bowl underarm. Okay? But then I think it just wasn't cricket when such a thing happens. It's a gentleman's game after all, so you can't do such things. Anyway, Republic of South Africa had to score 21 runs of the last one. The criterion that they used was the essentially, in some sense, the source of inspiration for the Duckworth-Lewis method. They used something called the most productive overs method. So in other words, basically, the team that essentially batted first was allowed to keep the most productive overs. That means if 2 overs were removed, the 2 least productive overs were essentially removed from the batting team's point of view. But this is kind of funny because South Africa is the one that is chasing, and they actually struggled to bowl really well, and these 2 overs were maidens. And what happened? They actually did well, and they were being penalized for having done well. South Africa restricted in these 2 overs them to about 1 run or so, but they were being penalized for this. The 2 good overs that RSA bowled were struck off, and it was being penalized for doing something well. Come on, this is ridiculous. This ought not to happen. Okay. And so this reporter asked on the radio immediately after the game, is there surely someone somewhere could come up with something better? Okay. And so enter FC Duckworth and AJ Lewis. Okay. All right. When the The proof of the pudding is in its eating, right? So we'll have to see how this particular method, Duckworth-Lewis method, fares in these two ridiculous situations: the West Indies-Australia game and the England Republic of South Africa game. Okay, so West Indies' initial target would have been 232 of 38 overs due to the 2-hour interruption during Australia's innings. But the revised target would not have been the 60 odd runs of 11.2. It would have been about 139 using the Duckworth and Lewis method. It would have been 139 of 11.2 overs. And this would have been a fair game because I think they had enough wickets on their hands, and it's possible prior to the interruption it was a sort of fair game. Post the interruption also it ought to be a sort of fair game, and therefore this seemed like a reasonable target. Australia could have been, there is also another reason why this target is somewhat higher than the 10 runs per over that I think some of you mentioned. I think what was the target roughly that you had mentioned? About 100 something, right? 100 or so. This is actually a little bit more. And that's because Australia started played for about 4 overs or so, and then rain stopped play and brought it down to 38 from 50. So had they known, or had they encountered, had they known that they would essentially have this eventuality, then perhaps they could have been a little more aggressive. Okay, so they could have taken that into account, and therefore West Indies was essentially set a higher target, given that Australia did not have an opportunity to make good of the fewer number of overs in the first few overs. Okay. What about the second game? What do you think would have been a reasonable target? From one ball. 3 or 4 runs. Okay. So here's what the Duckworth-Lewis method gives. Republic of South Africa would have needed 2 to tie and 3 to win. So 3 runs to win in one ball. Okay, that seems like a more, they had a fair chance prior to the break, and maybe this gives them a chance, but they can still fight and be in. Okay, there is actually a newer version of the method which says no, it's not 2 to tie and 3 to win, but 3 to tie and 4 to win. So depending on which version of the Duckworth-Lewis method you use, the outcome would have been different. Okay, both are reasonable targets. At least you will believe that yes, okay, this is something that's available. Okay, just to summarize the kind of interruptions that one will encounter in a rain interrupted cricket, or some other interruptions may also cause stoppages of play. Here's one kind of interruption. Before the first team's inning, something happens and you can't play the full 100 overs. Then it's quite simple. Both teams know before they start play that they're going to have fewer overs. What should you do? You should just shorten the game. Okay, so that's the easy case to deal with. There is possible interruption during the first innings. Okay, repeated interruptions could happen in the first innings, possibly, or maybe there is one interruption like in this Australia-West Indies game. You have to be able to handle that. There could be a stoppage of play in between the 2 innings. Okay, so that also has to be dealt with, or during the second team's innings, as in the South Africa and England game. In which case, we might have to shorten the game and we have to revise the target as well. But don't use the most productive overs method. Stoppage without reception, then you have to declare a winner. This is another possible situation. Okay, so is this clear? If you come up with a method, and all of you should think of, you have ideas teeming within you, so maybe you should think of a means by which you can come up with a method. The standard is now quite, the bar is high because the Duckworth-Lewis method is somewhat accepted now, but there is always room for one more method. So if you have a good method, perhaps one that takes into account the ground, then it would be considered. Okay, so these are the kinds of interruptions that we have to deal with. So it has been in use since 1997, and maybe I'll give some examples. The first game where it was used, okay, roughly what percentage of the games get affected by rain is another question. You come up with this method, but if rain affects only about 1 in 1,000 matches, maybe it's not worth putting this much amount of effort. It turns out that about maybe less than 10%, but a significant fraction, enough that it warrants a detailed study of this method. A significant fraction, about let's say 10% of the matches do get affected. I used to know this exact number, but I don't recollect the exact percentage, but it's about 10% or less. Okay. So here's the first time it was tried out in 1997. Okay, so it took quite a few years to develop, and then eventually it was being tried out about 4.5 years after the World Cup. 1992 World Cup came. Zimbabwe versus England. Zimbabwe played 50 overs and they scored 200 runs. And rain shortened the game to 42 overs during England's innings. And if you use the average run rate method, you would essentially get a score target for England of 169. But the Duckworth-Lewis target, whatever that method supplied, is 186. And therefore, England had to score in the, I don't know at which point it actually stopped, but they eventually scored 179 of the 42 overs. And so by the ARR method, they would have won. But the result was they lost according to the Duckworth-Lewis method. Okay, it has been the preferred method with some modifications for resetting targets in shortened games. There are many other methods actually. I just want to list out a few, and some of them were actually tried out in World Cups. ARR and MPO are two things that I already described, but there was a discounted version of most productive overs. There is also another method which was a sort of curve fitting method. Perhaps stands for some parabolic curve fitting. And so this provides diminishing returns for overs in terms of runs. So this perhaps took into account, anyway, so we'll see. This was a good approach, and I'll tell how the Duckworth-Lewis method essentially takes into account or discounts runs and overs in an appropriate way. An adaptation of this was essentially the one that was used in the 1996 World Cup, but that one actually ignored wickets in hand. So for 9, for no loss, for 2, 120 for 9, 120 for no loss, 120 for 2. That essentially ignored this particular aspect. There is another method called Clark method, which applies somewhat different rules for different kinds of stoppages. But what we would like is what Duckworth and Lewis wanted was a uniform method that you could essentially apply for all kinds of stoppages. Okay, something that would essentially deal with all of these kinds of stoppages in somewhat unified way. Okay, so I'll now describe the method, and I'll have just about time for that. Oh, there is, I must mention a method that has been put out by a person from India, and this is actually something that comes closest to the Duckworth-Lewis method. So, okay, what is desired of a good method? Maybe I'll skip this. Okay, here's the basis of the method. The batting side, whichever team is batting, whether it's batting first or batting second, it has two resources at its disposal. The two resources are overs and wickets. So let's actually look at the team batting first. It's trying to set a target. It has these two resources at its disposal. And what should it do with these resources? It should try to set as large a target as possible. Okay, maximize its score. Alright, overs to go and wickets at hand. Both of these matter and in some combined way, and we need to figure out in what way. And so 20 overs when 10 wickets are in hand, for example, is much more valuable than when you have only 1 wicket in hand. Okay. So if you have only 1 wicket in hand, chances are, if it is Harbhajan Singh, you might get a couple of sixes, but he's going to get out very soon. If it is Varun Arun, he's going to get run out in a couple of balls anyways. Okay, so team 2's target must essentially be reset based on the resources that it has before the interruption, in case there is an interruption for team 2. And you also have to take into account resources it has before the interruption and after the interruption. Okay. This should be such that ideally, and this is the ideal, but there are many words here which are left undefined. the relative positions of the two teams should be the same before and after the interruption. Okay, but what does relative positions mean? Okay, this is something that's subject to interpretation. Maybe I'll ask for a couple of thoughts on what relative positions, what does positions mean? So how would you measure relative positions? Any thoughts? Runs scored. So what you're thinking of is you're thinking of treating runs as some sort of resource, and you want to, some sort of wealth, and you essentially want to make sure that whatever wealth they have before the interruption, after the interruption also they have the same sort of wealth. There is another possibility. You can go and, sorry, someone interrupted me. Okay, so not, I think you have done probability and statistics. I saw that you had some session there. Maybe what you should look for is make sure that the probability of winning before the interruption and after the interruption remains the same. Okay, so that's also a valid criterion. It's called the ISO probability criterion. But what the Duckworth-Lewis method does is it essentially tries to keep the wealth sort of the same, equalizes the wealth, so to speak. Okay, so we'll view the total runs that can be scored as a function of overs to go and wickets in hand as the net value of the resources. Okay, so we have resources, overs and wickets. How much can you do with these resources? Okay, that's the wealth that you have. That's the endowment that you are left with. And if your resources come down, we'll essentially bring down your target also accordingly. Okay, and somehow we have to essentially make a mapping, get a mapping from resources to the wealth, the runs. Okay. So let's call that Z of U comma W. Okay. Z of U comma W is the number of runs that you can score when you have at your disposal U overs which are left and W wickets that are available. By the way, these slides are available on the web. Maybe I will indicate how you can get them so that you can go and take a look at it afterwards if you want. And so we need to come up with a method to identify what the Z of UW is. So I call this the run production function. Okay, the team batting first is like a factory. They have some resources and they're essentially coming up with products, and the products is runs. Okay, so some sort of an economic interpretation. Okay, what's their run production function? With this much wealth, with this much endowment, overs and wickets, how many runs can they score? Okay, suppose a team has all 10 wickets and it starts playing. What is the score that it can get when it has 40 overs, when it has 50 overs, when it has 60 overs? Okay, you just say that, okay, go ahead and play, you have 40 overs, you have all 10 wickets in hand. How much runs would you score? So let's take a look at it. If you have 20 overs, how much, let's come up with some numbers. How many runs would you score? You have all 10 wickets in hand, but you have 20 overs left. 120, 150, 150, okay, 20 overs, T20, 150 is sort of, what is par score these days? 180, okay, 180. Maybe you should say 180 because you have only 20 overs, but you have all 10 wickets in hands. And we have many examples where people have scored on the average, I think 160, 180 seems a little too high. Maybe 160, let us say, 8 runs and over. That's good with 10 wickets and 20 overs. But what if you have 40 overs? Will it be 160 times 2? 3? Okay, what will it be? So it's not going to be 320. But it's going to be something a little smaller. Okay, so straight away you see something that people in economics see. It's called diminishing returns. Okay, so if you have 20 overs, that means something. But if you have 20 more overs, and the same 10 wickets in hand, you're going to lose. You're going to take chances. You're going to lose wickets. It's not that you're going to last possibly all 40 overs. You may not be able to use it to the fullest possible potential. And so it's not like you're starting afresh in the second half of the game with 10 wickets in hand. Okay, you take a risk, you lose wickets. That's where you will start from in the second half. And therefore, it's not 160 times 2. Okay, there is diminishing returns. Okay, about 240 or so, 40 overs, 240 or so, 50 overs, Okay, it's not going to be that you just add another 80 again. So there's going to be some bringing down. So there is diminishing returns. So they play according to one-day rules, but let's just say that okay, you have 20 overs, you have 40 overs. It's a different kind of restriction. And what's the maximum that they can score? The total runs that they can score until they lose all 10 wickets in hand is actually a random quantity. But let's take an average and figure out. That's what you said. 20 overs, 10 wickets in hand, 160. 20 overs, 40 overs, 10 wickets in hand, 240 or thereabouts. So let's say that if you essentially play forever, I don't give any limit, with these 10 wickets, go and score as many runs as you can. Okay? I'll call that as Z0. Yeah, it's a random quantity, but I'll take its average. What do you think? No over limit. What would you score? Sorry? 400 or thereabouts. Okay. So what you do is you essentially come up with this and you model the average runs that you will score in some fewer number of overs in this particular fashion. So here's the maximum that you can ever score with no limitation. And then if you have a certain over limitation, you get 1 minus e to the minus p. So here's a plot. So this is your run production function. And this is when you have all 10 wickets in hand. But what if you have only 5 wickets? First of all, okay, this is only a model. You have to essentially find out what there are 2 parameters to this model. One is what the maximum that you said 400 or something, but is that really so? You can actually go and test in the data whether it is indeed the case, if this is the model that, if this is the pattern that past matches have. And also you can learn about B, what this exponential rate is. That is, the difference goes down to 0 at an exponentially fast rate, and that rate is B. U is the number of overs, B is the rate at which it decays. Okay? So you can essentially go using the data that's available, identify what the Z0 and B ought to be. But what if you have not 10 wickets, but 9 wickets or 8 wickets? Well, you can actually go and look at the history of games and come up with a similar model, except that the Z0 will be something a little smaller, and you will come up with another curve. Okay, and so here is a means by which you can actually go back and look in the database of all matches and identify the data points that you need and identify what Z0 and B ought to be. You can estimate them. I'll not worry about that. It's a fitting of the curve, and I have also provided this data set for those of you who are interested to play with. But what if you have a fewer number of resources? Then what you do is, let me just, if wickets have fallen, then you will essentially come up with a different multiplication factor. It will saturate at a different level. Okay, it won't go all the way up to Z0, which is Z0 of 10, but it will go to Z0 of 9 if there are 9 wickets in hand, or Z0 of 8, and so on. And so one gets a curve like this. One gets a curve like this. Okay, so this is the curve when you have all 10 wickets. This is the curve when you have all 9 wickets. This is the curve when you have, 9 wickets, when you have 8 wickets, and so on. One interesting feature of this curve is that the slope at this particular point is all the same. Okay, what is that indicating? Well, this is basically saying that the rate of change of this production function, okay, the rate at which runs will increase, when you have only epsilon, a very small amount of very small number of overs, the runs that you will score, that's the slope at this particular point. Okay, so that means that the marginal rate at which you will score, okay, marginal run scored per unit over, per unit of overs remaining, is all the same, and that actually sort of makes sense that they must all have the same slope, because if you have only one ball that's available, whether you have 10 wickets in hand or 9 wickets in hand or 8 wickets in hand, doesn't matter. Right? How many runs you can increment is the same. So that's the reason why all of these essentially have the same slope. And so what one does, I'll just say it in words and I'll stop. What one does is one finds out how many resources have been lost due to the rain. Okay, so let's say the team batting first plays and it scored 250. The team batting second played and let's say it lost about 20 overs. What you do is you essentially find out how much of the resource fraction has been lost. Okay, and because we essentially have this, you use this information to figure out what the resources lost is, and therefore what resources they have, and you essentially go down in proportion of the resources that have been lost. So that's the essence of the Duckworth-Lewis method. I've run out of time, so I'll stop here.
Okay, thanks a lot, sir, for the absolutely engrossing, intriguing talk. I'm myself a cricket fan, and I think I became a bigger cricket fan now. I'm sure everybody here does. And probably